Rational exponents. A rational exponent, the word rational refers to the type of number. So if you remember, a rational number is any number that can be written as a ratio of two integers, or basically our fraction. So a rational exponent is a fractional exponent. Okay, so for example, 3 to the 1/2 power. Okay, that would be an example of a rational exponent. So let's quickly remind ourselves about our properties of exponents, and let's look at some examples. So if we take 3 to the 4th power, that's 81. 3 to the 3rd is 27. 3 squared is 9. 3 to the 1st power is 3. And notice each time here we're dividing by 3. Okay, as we go down. So it makes sense that 3 to the 0 power is 3 divided by 3, which is 1. Okay, and it brings us to, if we continue this pattern, we can figure out what it means to have a negative exponent. 3 to the negative 1 power means 1 over 3. Okay, so 1/3. And 3 to the negative 2 power is 1/9. Okay, and now you see that the negative exponent indicates that we just bring this to the denominator. Okay, if 3 squared is 9, 3 to the negative 2nd power is 1 over 9. So, but we want to talk about, okay, what is the value of 3 to the 1/2 power? Well, it makes sense if 1/2 is between 0 and 1, that 3 to the 1/2 power should be somewhere between these two values, 1 and 3. Okay, so 3 to the 1/2 power should be somewhere in there. But what is the value exactly? Well, let's look at this. If we take 3 to the 1/2 power times 3 to the 1/2 power. Okay, our properties of exponents say that if we have the same base, we add our exponents. So this gives us 3 to the 1/2 plus 1/2, or 3 to the 1st power. Okay, well, how does that help us? Well, 3 to the 1/2 times 3 to the 1/2 is just 3 to the 1/2 squared. Okay, and what that means is that squaring this undoes whatever operation this 1/2 power does. And if you remember, we saw that once before. If we took the square root of 3 and we squared it, we got 3. So it leads us to the conclusion that 3 to the 1/2 power is equal to the square root of 3. So in general, we have the property that the square root of a to the n is equal to a to the 1 over n. Okay, that's the equivalent rational exponent. So we saw that before. We saw that if we took the square root of 3, that was equal to 3 to the 1/2 power. Okay. Same thing, we can look at a few other examples. We can say, okay, the square root of 36 is equal to 36 to the 1/2 power. We can also say the cubed root of 64 is equal to 64 to the 1/3 power. And the fourth root of 16 is equal to 16 to the 1/4 power. Okay, so notice we haven't simplified any of these. All we've done is rewritten them from radical form to rational exponent form. Okay, and we can go backwards. If we have 64 to the 1/3 power, we can rewrite that as the cubed root of 64. So let's look at some other examples. What is the simplified form of each expression? So we have 216 to the 1/3 power. So we're going to rewrite this as 216. Okay, the denominator is 3. Okay, so that becomes our new index. Okay, so now we have just rewritten that, and then we can simplify this as usual, and I'll quickly do this. I'll let you, if you want to pause it now and try to simplify this, you can, but we'll go ahead and simplify this. I can write 216 as 6 to the 3rd power. Okay, and so I can say this is equal to 6, because taking the 3rd root of something to the 3rd power just undoes that, and I'm left with 6. So this is using our simplification properties that we've done in the last couple sections. We have 7 to the 1/2 times 7 to the 1/2. We looked at an example like this earlier. We could simply use our properties of exponents. So there's two ways of doing this. We can say, okay, method 1, we can add our exponents, 7 to the 1/2 plus 1/2, which is 7 to the 1st, or just 7. Or we can rewrite it as the square root of 7. 7 to the 1/2 power is the square root of 7 times the square root of 7, which we know gives us the square root of 7 squared, or 7. So either way is fine. It's up to you how you want to attempt that. So this brings us to a more general rule. If we have the nth root of a, and it's a real number, okay, m is an integer, and m divided by n is in lowest term, so we have a fraction in lowest term, so we don't have 4/8, we have 1/2 instead. Then a to the 1 over n power equals the nth root of a, and a to the m over n power is equal to the nth root of a to the m power, or the nth root of a all raised to the m power. Okay, so let's look at what that means in practice. So if we have x to the 3/7 power, what this is saying is that my denominator is my index. Okay, this becomes my index, And this is the power that I am raising my radicand to. So my index is my denominator, so 7 goes there. My numerator is what I'm raising this to. Okay, and that is also equivalent to saying this. Okay, that is equivalent. These two expressions are equivalent, so whichever way you prefer to write this is fine. Okay, so that is what that means. So let's take a look at another example. If we have the fifth root of b and we raise that to the third power, okay, we can go the opposite direction. This becomes my base, okay, the radicand is my base. This is my numerator, and the index is my denominator. Okay, so those are equivalent expressions. Here are some properties of rational exponents, which are the same as the property of your integer exponents as well. Okay, so you can review those. They are on page 383 in your book as well. So we can use this to help us simplify some radicals, okay? We might look at this and not really know what to do because we can't simplify what's in the radicands at all, and we don't have the same index, so we can't use our regular division rules. So I'm going to rewrite these. If I rewrite the top, I get remember, this is my denominator, this is my numerator, so I get x to the 3/4 power divided by x to the 2/8 power, okay? And now I'm going to simplify this fraction. I can simplify this fraction. So I get x to the 3/4 over x to the 1/4. And now I can divide these using my exponent properties, which says that if I divide two numbers that have the same base, I'm going to subtract their exponents. So this becomes x to the 3/4 minus 1/4, which is x to the 1/2. And we know that x to the 1/2 is equivalent to the square root of x. Okay, so this expression is equivalent to the square root of x, which is this is a lot more simplified to look at. Again, we're going to simplify. We use our properties of exponents. That says that we are going to raise everything in the parentheses to the 2/3 power, so we get -8 to the 2/3, okay, times x to the 2/3 times, now I'm going to rewrite this is xy, but this is xy to the 1/2, and I'm raising that to the 2/3. So now I can multiply these two, so I get -8 to the 2/3, x to the 2/3, and xy to the 2/6.